All right, so we've got a great combination.
So now we've got
energy
the pre-response question
momentum.
for
And
Unit
so you
5.
see a lot of
So here we've got a
pendulums, these
nonlinear
loop-de-loop
spring.
things.
So
And we're looking at
great
graphs
for
the AP
pre-response
questions,
or
or even
graphs, and
sometimes
they're
smaller
kind of particular about
versions
things
in
that they're
multiple
graphs.
choice
So,
questions. So small block is
And if you
initially at
notice
rest.
here,
And look,
it
we even
says
get a
be
circular
sure to show
motion.
your work and specify the
At the bottom of
units
the
because
circular
that
vertical
means they're going to
loop
assign
shown
points to
above
that.
Radius R.
Surface
And
contact
so
between
let's
the
take a
block
look
and
at
is
our
frictionless
rubric
here.
A bullet mass M strikes the
so
block with the horizontal
for part
velocity
A,
of the initial.
you
remains
get
embedded in the
a
block.
point
And the block
for
then continues
correctly calculating
around
constant
the
A.
circle.
You could have used either the left hand or
and everything's
the
got
right hand graph.
M, V naught, R,
Substituting
G.
in. So
Got
if you
the
use the
speed of
right
the
hand
block and
graph,
the
you
bullet
would have
immediately
found the
after
slope of the
impact.
line.
So hopefully you clue in right there.
And
Conservation
so
momentum.
you
It's a
would have found the
collision.
slope to be
All collisions
25.5
have
newtons
conserved
per
momentum.
meters to the
The
1/2
energy
power
of the block,
kinetic
and
energy of the
so
block
showing
and
that work
at
as a
point
point.
P, so a quarter of the way through the circle.
Then
Then having a numerical value
and
that
minimum
ranges somewhere between
initial
23 and
speed needed for the
27
block
would be a
and the bullet
point,
to make
and
it
then
all
having
the
the
way
correct
around.
units is another point.
Okay,
so
so
that's why
let's
they were
take a
so
look
particular
at our
on finding on saying show
rubric
the unit for this. Okay.
Okay.
And then
So,
let me go back to the
some
problem. Part
statement
B,
of
you're going to
conservation
determine an
momentum.
expression
Saying
for the work done.
momentum
in
is
compressing the
conserved.
spring a distance
Counts
of
for a
x.
point. You could say P
Since
initial
this is
equals
a
P
nonlinear
final.
spring,
Or,
you can't just use
MV initial equals
force equals
something,
negative
okay?
kx.
So for having
to
the
plug into
correct
your work.
equation,
Now your
MV
force is
naught
equal
equals
to
3m
x to
V
the
because you've got
1/2.
the bullet is M, the block is 2m.
And you need to
You get a
explain in
point,
a few sentences
and
how
then
you
solving for the velocity.
could use one or both of the graphs
is
to
the point.
estimate the numerical value that you find
For
in the
part
first
B,
part.
some
of the
statement
answer.
about the
So,
conservation of energy. Energy is
part
conserved.
B.
E naught equals E final.
Or
Again,
having
since
this
you're
correct
doing it over
equation
some
with
distance,
the
potential, and
and
kinetic energies, I believe
you
would
have a
also
function
count.
you're going to want to use work
and
as
so
the
you would be awarded
integral
2 points
of
here
force
because you
dot,
had both
they say ds
the
here.
correct equation
you
for
had used
potential and
X,
kinetic
that's
energy
fine.
and showing that
Okay?
energy is
So
conserved.
you get a point for having,
But
just to be safe, that always makes some
formula down. So
generic
always
statement
write
first.
formulas. Correctly
Okay.
substituting in the
Substituting
values
in the
gets you
correct
2
expression for
points
force
here.
gets you a point, and setting the correct limit.
Now you
from
have to
0
have all the
x,
terms
that's
correct to
another
get
point.
both points.
Doing
Okay?
the actual correct
And then
integration
finding
gets
the
you
kinetic
the
energy
fourth point
or some
for
equivalent,
part
you
one
get
of
2
part
points. So
B.
that means if you didn't simplify it the same
For
way they did, or
part
you
two,
went further in your simplification, that's
for those points,
Okay.
you could say
Note
you could find
here,
the area
if you
equal
found the
under curve,
velocity
the left-hand
instead
graph,
of kinetic energy, you still got
or
full
having
credit.
a correct explanation
For part
obtaining
C,
the area
then,
under the
you've
graph.
got to make it all the way around the
So
loop.
we
we
want to
take
know
points
what's the initial
velocity needed.
part C.
And so you're
Let's
going
go back to the question
to,
to make sure we know what we're being asked.
Conservation of energy again.
Oops.
Okay, so
Okay.
your initial kinetic energy, having that correct, having
Part
your velocity
C, the spring is mounted
there
horizontally on
is
a
a point,
countertop that is
having the
3.1
correct
meters high,
final,
so that its
potential
equilibrium
energy, so
position
that
is
would be
just
at
at
the
the edge of the
loop.
countertop. The spring
Is
is
1 point, and
compressed so
notice
that it
that
stores
you have to have your height be
0.2R,
0.2
because your joules of
the full
energy
diameter
and is then used to launch a
Okay.
ball of a mass of
and
0.10
then
kilograms
your
horizontally
V top,
from the
you
countertop.
still have
Neglect
kinetic
friction
energy at the top.
Determine the
So,
horizontal
gotta make
distance
it
d
over.
from the edge of the countertop. So
Okay.
we've also got conservation of energy
so
going on in
then
this problem too.
You need to
So,
show that
using
at the
conservation
top,
of energy gets you a
there's
point.
no normal force. It's
Here,
only
there's not
gravity
an
that's
actual
providing the
statement point,
centripetal force.
But I
so
still always like to make
when
that
you
statement
have that,
because
when you
never know when it's
recognize
gonna
that
be
and
down.
show that recognition, you get a point.
Okay, your initial
And then saying
potential
gravity
energy
then is equal to
is going to be
centripetal
what's stored
force.
in the spring.
Solving
your
for the velocity
kinetic
at the
energy
top
is going to be equal to that.
and then is another
Okay,
point.
so you substitute in the
Plugging
value
that
for your
back into
potential
your
energy
energy,
equation is a point,
and
and
you
finally
solve
solving
for the
minimum
velocity
as
is a
the
point.
ball.
So lots of energy here.
Leaves the countertop.
You got some
I'm
centripetal
sorry, acceleration and force here.
Yes,
You've
as
got
the ball
all
leaves
sorts
the
of things
countertop.
coming into play.
Okay.
This is a great
And then you're into
question.
kinematics.
So you're going to
Let me
find
know
how
if you need
long
more
it takes
details
before
the
these
ball hits the
explanations are
ground.
getting shorter because we've gone through more and more by the time you get here. And then you can determine the distance it moves because you know horizontal velocity is not going to change. You know that the time it takes to fall is going to be the same as if you dropped the ball, and so now you can find the distance that the ball will travel horizontally from the countertop, and that's 1 meter. Okay? Any questions further than this, you just let me know.